Thank you, Dr. Teresa Herbrand, for showing us just how powerful and wonderful mitochondria are, converting the nutritious food that we eat and the air that we breathe into energy, the spinning power plants that produce energy, which we call ATP. First, I'd like to ask each of you, take a deep breath in through your nose, hold it for 5 seconds, and then breathe out through your nose. Ready? Go. Now hold it for 5 seconds. 1, 2, 3, 4, 5. Out through your nose for 5 seconds. 1, 2, 3, 4, 5. Now I'd like to ask you to close your eyes really tight. Hold it for 5 seconds. Ready? 1, 2, 3, 4, 5. Now open your eyes. How do you feel? Wonderful, right? You just deeply supplied oxygen into your lungs, into your blood, to your cells, are required to produce energy in your mitochondria. You also allowed your retina, which has a tremendous amount of mitochondria, to relax from all the visual stimuli inputs. I'm Dr. Kevin Ham from Vancouver, Canada, and it's my great pleasure to talk to you today about your health, especially about your mitochondrial health. As you've heard, mitochondria are the power plants of your cells. You saw from Dr. Dieter's talk that sunlight provides energy to the plant. In the same way, sunlight provides energy to water. 70% of this earth is water. 70% of our bodies are water. And this energy sets up the necessary conditions to set up the electrical gradients inside the cell and between the cells so that mitochondria and energy production are easily done within the cells to do life processes. And the light sets up the charges around these proteins, these fats, and mitochondria, produces negative charges around them, and in between them, there are positive charges. This creates separation of the proteins, the fats, the organelles, as well as the separations of cells. And these charges make the liquid, the cytoplasm, more gel-like. So we're not just a blob of water. And inside our mitochondria, we have this membrane. And inside the membrane, we have these complexes which form the electron transport chain. And these produce the energy. But in order for these to work, it requires certain metals, certain elements, such as iron, sulfur, copper, magnesium. So the iron-sulfur clusters are necessary in order to help with the electron transport chain. Every time the ATP synthase spins 9,000 times per second, it requires 2 copper atoms. And every time ATP is produced, it requires magnesium to stabilize it in the cytoplasm. So where do we get these metals and elements? We get them from our food, and these come from the soil. So iron is plentiful in meat, heme iron, in liver. We don't need to take a lot of liver, maybe 3 ounces of grass-fed liver once a week. You can get it in spinach and beans. So iron is the most plentiful, so that should not be a problem. Sulfur is the 3rd most abundant element in our body after calcium and phosphorus. So you can easily obtain that through the amino acids and proteins. You can get it from broccoli, which has sulforaphane. You can get it from eggs. Maybe that's the reason why eggs smell. You can get it from meat, organ meat, garlic, onions. The one that we should consider is copper. We don't need a lot of it, only 900 micrograms per day. We can get it from liver. We can get it from oysters, have a lot. Spirulina, which is blue-green algae, shiitake mushrooms. Magnesium, you can get from dark chocolate, cacao. Opt for the 90% cacao, bit bitter, but it's healthier than the 30% cacao. It typically has more refined sugars. You can also get magnesium in avocados, chickpeas, so forth. A lot of the foods are grown on big farms, and these farms are using herbicides such as Roundup otherwise known as glyphosate, typically for corn. And this Roundup or glyphosate binds to a lot of these heavy metals, especially copper. I'd like to talk about two types of respiration. Aerobic respiration, which uses oxygen, and anaerobic, where you no longer use oxygen, produce energy. So typically when you're walking, talking, moving about, you're using aerobic respiration. This is what you've learned. The glucose and the oxygen produce energy. Oxygen binds with hydrogen, produce water and carbon dioxide. This water that is produced as a result of energy production is one of the best waters for yourself. And the waters inside fruits and vegetables are an extremely great source of water. Now, as you're starting to work harder, you start to run out of breath. The demands of the muscles requiring the oxygen is lacking. And so you shift into not using your mitochondria for energy production, but just glucose to pyruvate that produces 2 ATP, 18 times less than the 36 ATP produced from all the mitochondria. And this leads to lactic acid buildup. And as you go in anaerobic respiration, you're huffing and puffing, you start to get tired, you start to get pain, and then you start to cramp. We've all experienced this. And so then you have to stop, catch your breath, go back into aerobic respiration. And so you actually want to get to the point of near anaerobic threshold regularly throughout the week so that you're stressing your mitochondria. Now, we talked about how glucose is an energy source giving you 36 ATP, but a more efficient, cleaner energy is actually utilizing fats. Fats typically have 18 carbons or more, glucose only has 6. And so when you need to use fats as an energy source, when is that? It's when you sleep, when you skip a meal, when you're starving. Your body starts to break down your fat to produce something called ketones. So olive oil contains the fat oleic acid. Oleic acid at 18 carbons. It produces 118 ATP, 3 times more than 36 ATP from the glucose. So fats are a lot cleaner, more efficient form of energy than glucose. You can go a lot longer. The average healthy individual is 100,000 kilocalories stored in their fat. Give you a context. If you are exercising for 3 to 4 hours really hard, you're burning 2,000 calories. The amount of energy stored in a healthy individual is a lot of energy. Now, if you're overweight or obese, you have even more of energy stored in you. That could be seen in nature when bears hibernate over winter, they're burning their fat, and they can survive the winter without eating. So how do you strengthen and multiply your mitochondria? For example, if you're stressing your muscle cells, you might have 10,000 mitochondria. You can get up to 30,000 mitochondria in a muscle cell. You could develop more mitochondria in each muscle cell. And so how do you do that? You have to stress it. High intensity interval. This might be happening when you are climbing up stairs. Maybe you're on the 4th floor, and so you have to climb up the stairs, 4 flights of stairs. Maybe it's carrying suitcases. Maybe it's moving. So these high intensity intervals, maybe when you're walking, you're running for the bus. But if you're doing that 3 times per week, and in a 30-minute session, you're doing maybe 10 or 20%, 3 minutes, 6 minutes, 10 minutes of the 30 minutes at high intensity, then over 20 years, your fitness level, your cardiac health, your heart health, your lung health, mitochondrial health might only decline 6%. That's quite amazing. 3 times per week, 30 minutes, and just 10 or 20, maybe 30% of that high intensity. The other period is for recovery. So maybe you do 1 minute, 9-minute recovery, breathing, walking, and then go hard, jog, sprint, a fast pace for 1 minute, 9-minute rest. So that's just 3 minutes out of 30 minutes, and you can increase that. Now what that will do is allow more efficiency so your resting heart rate becomes lower. Typically, most people are 60 to 100. Elite athletes are at 30, 35, under 40. I'm 43 resting heart rate. But that's because I do a lot of aerobic activity. I cycle a lot. And that means my heart doesn't need to work as hard at rest. And then when it's stressed, it also doesn't work as hard as if I was not cardiac fit. So what is your resting heart rate? You can measure that over 1 minute as you just sit down. And then what's your heart rate when you are walking or jogging? You can measure that on an Apple Watch or a Fitbit. And you should get up to about 220 minus your age. So if you're 50 years old, 220 minus 50 equals 170. Just try to maintain 170 for 10 seconds, 20 seconds, 1 minute. So instead of taking the elevator or escalator, take the stairs. When you get up from bed, get up, lie back down, get up. Do that 10 times, 20 times, 30 times every day for the next 30 days, next 60 days, next 90 days. As it gets easier, do more. When you get up from your bed, squat down all the way to the ground. Do that 10 times, 20 times every morning. Touch your toes, hold it for 1 second, hold it for 10 seconds, hold it for 1 minute, hold it for 2 minutes. Play music, learn languages, use your brain as activity. Do planks, isotonic. You get on the ground, you fold a plank. That does all your upper body, all your core, all your lower. Hold it for 10 seconds. Do it every morning. Then increase to 20 seconds after 30 days. And after another 30 days, increase to 30 seconds. Just keep on going until you get up to 5 minutes even. You'll be so fit by that time. Do some jumping. Now, astronauts, they need to be very physically fit because they have to withstand the G-forces as they enter into space. But once you're in space, there's no gravity, and their muscles become smaller and weaker. And when they come back to Earth, they can barely walk. Same thing happens when a leg is in a cast. That leg, over 6 to 8 weeks, becomes smaller in size and weaker. Sometimes it takes 1 or 2 years just to get it to the same strength and power as the good leg. So when you don't use it, you lose it. And this applies to every single part of your body. Now, if you're not using it, what happens is that the ATP is not recycled back to ATP. The average cell uses 10 billion ATP per day. And in order for this to happen, the ATP needs to be recycled back to ADP 1,000 times. And so if ATP is not being used, you're eating a lot, you're eating late at night, what happens is there's a backup, a traffic jam in the electron transport chain. And remember with the oxygen-free radicals that was waiting for the hydrogen to produce water and produce carbon dioxide? Well, that starts building up. Now, oxygen-free radicals are very greedy. They start attacking proteins, DNA, lipids inside the mitochondria, start damaging the mitochondria. That leaks out into the bigger cell in the cytoplasm, starts damaging all the proteins and fats, the DNA in the nucleus, and then that gets into the blood and starts the process beyond just the cell. So you get a highly oxidative or highly inflammatory state where your lipids and proteins and DNAs are getting oxidized and damaged. Eventually that leads to fatigue, poor energy, and those systems or cells where it's highly impacted that require a lot of energy, you start to have immune dysfunction or hormonal dysfunction, metabolic dysfunction, and eventually disease. Now I'd like to introduce you to someone who was awarded the Nobel Prize in 1931 for his discovery of the respiratory enzymes in cellular respiration. He lived in Germany, he was Jewish, he was gay, and he never left Germany during the Second World War. It is said that Hitler commissioned Otto Warburg, despite him being Jewish and gay, find a cure for cancer. Hitler's mother apparently died when he was 7, and so he tasked Otto Warburg, find a cure for cancer. And what Warburg discovered was that most cancer cells cannot use their mitochondria for energy production, that 36 ATP at aerobic respiration. And instead, it will just use glucose to pyruvate, produce 2 ATP, 18 times less. That's like anaerobic respiration. So cancer cells need a lot of glucose in order to multiply. So what does this mean? If you have a diet high in sugar, high in glucose, high in carbs, you're facilitating the growth of any cancer cells. If somebody has cancer, should reduce all the refined sugars, the carbs, as much as possible, stress on the cancer cells. Your body would produce ketones that all the healthy cells can use as fuel, more efficient, right? 118 ATP versus the glucose, which is 2 ATP. So when you're in a fasting state or keto state, any cancer therapies like chemotherapy, radiation work a lot better. Less side effects because the healthy cells are still able to be utilizing fats as energy, and the cancer cells are distressed because they don't have enough fuel sources. So what makes unhealthy mitochondria? We know that radiation does. I'd like to ask each of you to find out how much radon might be in your house. You're going to get a radon kit, measure it. If you have high radon, it's the second leading cause of lung cancer after cigarette smoking, but it takes decades of breathing in the radon, which typically comes from the foundation, from the stones, from granite. And you either vent it out or you should leave your house. EMF, electromagnetic frequencies, the wireless non-ionizing radiation, they seem to be disrupting cellular signaling. So try to limit the amount of EMF in your bedroom, especially when you're sleeping. We talked about unhealthy foods, especially processed fats that are heated. Omega-6 oils, omega-3 oils that are heated are especially damaging to mitochondria, highly oxidative. Refined sugars, we talked about eating too much without using that energy puts a lot of stress on the mitochondria, as well as eating too late. Your mitochondria need time to restore and rejuvenate. And also psychological, emotional, mental stress produces high cortisol levels. Is that hormone, stress hormone? It's okay temporarily, but over chronically a long period of time, it produces an inflammatory oxidative state. So how to reduce stress? Getting away from the city, finding some me times, walking in nature, meditating, praying, forgiving, being generous, doing acts of giving rather than just getting. And healthy mitochondria, as we spoke about, you need good sunlight, set up the conditions for life, for energy, good air, good water, exercising, walking, high intensity intervals, flexibility, strength and resistance, as well as endurance. We talked about nutritious food. And one of the keystone pillars is also rest, quality sleep. So paying attention to light and night. A lot of hormones like melatonin is produced in the light, released in the night. And growth hormones released in the night. And cortisol builds up towards the morning. So a lot of these hormones get disrupted if you're not sleeping properly, or not obeying the laws of light and night, and also of seasons, summer and winter. So try to get good quality sleep and rest where you recuperate. So in summary, get good sunlight, eat organic, nutritious foods, move more energetically with intensity, regularly, consistently over decades, and more so pay attention as you pass your 50s and get older in each decade. Find a way to reduce stress, to detach, get away, to recover, retreat, and to sleep well. So I ask that you determine in your heart to make some decisions to incorporate one or many of these things starting today, right? Starting a habit, an exercise that's high intensity, that gets your heart rate up, that changes some of your toxic foods into nutritious foods for you to get away from stress, into peace, and sleeping and recouping well. So I wish each of you a long life, and I look forward to hearing about your health journey. Thank you very much.